Yes, this video is on regression analysis. Let us remember the basic concepts which we know about regression analysis. Regression analysis, it is about the average relationship between the variables under the study. If we know that there is sufficient correlation between two variables, we may be interested in estimating the value of one variable when the value of other is known, and that is done using regression lines. There are two regression lines if you are dealing with two variables. The one is the regression line of x on y, and the second one is the regression line of y on x. Here this bxy is called the regression coefficient of x on y, which is computed as r into sigma x by sigma y, and byx is called the regression coefficient of y on x. Okay. Signs of bxy, byx and r are the same. If this is positive, these two things are also positive, right? They are all the same. If r is equal to plus or minus 1, the regression lines coincide, they are parallel, and the angle between the regression lines will be 0. When r is equal to 0, the angle between the regression lines will be 90 degree. The regression lines will be perpendicular to each other. Okay. The geometric mean of regression coefficients is you multiply and take the square root. That is the geometric mean, right? The geometric mean of two regression coefficients, you get r, right? The square root plus or minus r, right? The geometric mean of two regression coefficients is the correlation coefficient. And correlation coefficient is not affected by the change of origin and scale. Even if you reduce a and divide by b, and from y if you reduce c and divide by d, the correlation will remain the same, right? And what is the effect of change of scale on the regression line? If you change the origin, regression coefficient will not be affected. If they change the origin again, the regression coefficient will not be affected. But if you change the scale of the variables, regression coefficient will be affected. So actually your variables are x and y. If you change the variables, transform the variables as x minus a by b and y minus m by n, the regression coefficient of u on v will be b by n bxy, right? You should multiply by this factor, and the regression coefficient of v on u will be n by b into byx. Okay, right? If bxy is less than 1, byx, if one of the coefficients is less than 1, the other will be greater than 1. And the intersection we have discussed, where the regression lines, they get intersected at the point x bar comma y bar. Okay, fine. With this idea, let us go to the problems. Which of the following measures the change in y corresponding to a unit change in x? Change in y corresponding to a unit change in x is given by the regression coefficient of y on x. Okay. bxy and byx are independent of the change of origin only, no, scale only. Okay. They are independent of the change of origin only. They are dependent on the change of scale. Okay. The regression equation x on y, in the regression equation x on y is called what variable? Y on x on y, right? So y is the independent variable or explanatory variable, right? X on y will be of this form. So y is the explanatory variable which explains the variable x. The line of best fit to the observed data is regression line. It is not correlation coefficient or standard error. Okay. If r is equal to minus 1, the two regression lines will coincide. Okay. They are not perpendicular. They don't have acute angle. They coincide. Okay. When r is equal to 0, the regression lines will be perpendicular. When r is equal to plus or minus 1, the regression lines will coincide, and when r is equal to 0, the regression lines will be perpendicular to each other. bxy is greater than unity. The property says if one of the regression coefficient is greater than unity, the other will be less than unity. Then among these choices, what may be the possible value of byx? This is the only choice. Since bxy is greater than unity, byx should be less than unity. These numbers are all greater than 1. Okay. The intersecting points of two regression lines are, the regression lines cut each other at their means, right? X bar comma y bar. The intersecting, okay, next question. If byx is positive, what is the sign of? It should be bxy, okay? byx is positive. What is the sign of bxy? This is also positive, because the regression coefficients will have the same sign, okay? They reflect the direction of the movement of the variables. If both the variables are moving in the same direction, the coefficients will be positive. If the variables are moving in the opposite directions, the coefficients will be negative. All the coefficients, the regression coefficients, the correlation coefficient, everything will be negative when the variables are moving in the opposite direction. If bxy is minus 1 by 12 and byx is minus 4 by 3, what is r? R is equal to plus or minus square root of bxy into byx, square root of minus 1 by 12 into minus 4 by 3. See, if you have plus or minus here, because this formula, whatever be the value, positive or negative, it is going to say the answer is positive. So to consider the sign, you use this plus or minus. If both of them are negative, take negative. Okay, 1 by 9. Right? If you take the square root, it is minus 1 by 3. Minus 1 by 3, option D is the right answer. The product of two regression coefficients. The product of, what is the product of two regression coefficients? See, r is equal to plus or minus square root of bxy into byx. Take a square the equation on both sides, you get this. Right? If you multiply two regression coefficients, you are going to get the square of correlation coefficient. You know the square of correlation coefficient lies between 0 and 1. Right? So the product of two regression coefficients is equal to 1. No, it is not so in all the cases. Greater than or equal to, no, definitely not. Less than or equal to 1, yes, this is correct. Equal to 0, you cannot say. So equal to, less than or equal to 1. In some cases it may be equal to 0, but in general it is always less than or equal to 1. Okay. If we have only one regression equation between two variables, what is r? If you have only one regression line, means what? When the regression lines are parallel, when the regression lines will coincide or when they will be parallel, when r is equal to plus 1 or minus 1. Right? Plus 1 alone, minus 1 alone is not the answer. Minus 1 or plus 1 is the right answer. Okay. So the tricky questions in regression analysis, let us have in the next video. Okay. Thank you.